Today I'd like to go over how to balance redox reactions or oxidation reduction reactions by using the half reaction method. And in this first example, this reaction here is, let's say it's in acidic solution, which means that we're going to end up with some hydrogen ions in our final answer when we balance this. Okay? So let's give it a try. The first thing we need to do is take this original equation that we're going to try to balance, and we need to break it up into two half reactions, are called. Okay, the one half reaction would be an oxidation reaction, and the other one would be a reduction. So it doesn't really matter if you know which one is which. You just have to be able to break it up into two halves. So I see that I'm going to look for similarities on the left-hand side of the arrow and on the right. I see a ClO3 negative here and a ClO2. So those are very similar. So I'll consider that one half reaction. So here's a half reaction. I'll just abbreviate reaction. And that would be ClO3 minus on the left, and then on the right we're going to get ClO2. Okay, the other half reaction that we're going to have, we'd look for like this one here, chloride, so Cl minus on the left, and on the right Cl2. Like I said, it doesn't really matter if you can recognize at this point which one is oxidation, which one is reduction. I can see here this is going from -1 to a 0 charge, so that's increasing in charge or oxidation number. So this one here would be the oxidation. But even if you didn't know that, you could still balance this equation out. Okay, so let's go through some steps here. The first step is to look at the first half reaction and balance the elements. Balance out the elements. So we have one Cl on the left, one Cl on the right, so they're balanced. However, with the oxygen, not so good. We have 2 on the right and 3 on the left. So what do? Well, in order to balance the oxygens when everything else is okay, you need to add water to the side that has less oxygen. So add H2O. In this case, all I need to do is add one H2O, because that'll add 1 oxygen. And now we have 1 plus 2 is 3 on the right, and we have 3 oxygens on the left. However, if I add if we add a water to the right-hand side, that adds 2 hydrogens with it, doesn't it? So I need to add 2 hydrogens. And since this is an acidic solution, and acid means excess H pluses, that means I add 2 H pluses to the left to balance out the 2 H's on the right. So now my hydrogens are balanced. Notice I put a plus here. That's very important. Don't just put 2 H's. Put 2 H pluses. Okay, so now my elements are all balanced. The next step is to check the charges. Okay, are the charges balanced? And we see here that we have a -1 and a +2, so that gives us a +1, doesn't it? And over on this side, there is no charge, it's 0. The charge must be the same on each side of the arrow. This is a +1, -1, and +2. So I need to make it have the same charges on the right, which is 0 in that case. So I'm going to add 1 electron, which adds a negative to this left-hand side. So now it's 2 negatives and 2 positives. That's 0 on the left, and it's 0 on the right. So now the charges are balanced. So the steps were to balance your elements. If there's a lack of oxygens, add water. When you add water to one side, you have to add H pluses to the other. Once you get that done, then you need to balance the charges by adding the appropriate number of electrons. Now let's look at the other half reaction. In this case, we have 1 chlorine on the left and 2 on the right. So we need to double the number of chlorines. There's no need to add water or H pluses because all the elements are balanced. So now we need to look at the number of electrons we have to add. So we have 2 times 1 is -2 on the left, and it's a 0 on the right. So I need to add 2 electrons on the right in order to make this side have a -2 charge, just like the -2 charge on the left has. Okay, so far so good. Alrighty, now we're going to try to add these two half reactions together so that we can end up with our balanced redox reaction. The thing is, though, we don't want to end up with any electrons left over. And I can see when I add these two equations that we're not going to be able to cancel our electrons properly. So what I need to do then is I notice there's 2 electrons in this half reaction, but only 1 electron here. I'm going to need to multiply every term in this first half reaction by 2, so I can end up with 2 electrons in this first half reaction. So 2 times 1 gives me 2. 2 times 2 gives me 4 hydrogen ions. 2 times 1 gives me 2 electrons there. 2 times 1 gives me 2 here. And 2 times 1 water gives me 2 there. Okay? Now we can add. So add this half reaction plus this half reaction. Since we have the same number of electrons here and the same number of electrons here, they're going to cancel out. Okay? So I can either do that now or later. I'll do it later, I guess, so people who are brand new at this can see how that works. So now I'll just go ahead and start adding them up. So we have 2 ClO3s, negatives, plus 4 H pluses, plus 2 electrons, plus 2 chloride ions, equals, or arrow, 2 ClO2s, plus 2 H2Os, plus Cl2, plus 2 electrons. Okay, now we can double check and combine like terms, simplify where needed. I see that we have 2 electrons on the left, 2 electrons on the right, so I can subtract 2 electrons from each side, and that will eliminate the electrons, which is a good thing because you don't want to have any excess electrons in your answer. The electrons need to cancel out because if you think about it, in a redox reaction, the oxidation half donates its electrons to the reduction half reaction, and so the electrons are basically used up, if you want to call it that, and taken in to these compounds. So there aren't any excess electrons left over. So then the answer would just be this without the 2 electrons on each side. So there's the balanced equation. Okay? I don't see anything that can be combined or consolidated, so this is the answer. And since this was in acidic solution, it makes good sense because see, we have hydrogen ions in the solution, which means that's what makes it acidic. Okay? Let's take a look at one more example. This time we have a reaction that is occurring in a basic solution. So now let's balance this one. Okay, so we're going to have to split this one up into 2 half reactions. So we'll look for similarities. I see this over here, and I see copper and ammonia over on the right hand side. So one half reaction we'll have this on the left and these two on the right. So 1/2 reaction. So that'd be CuNH3, 4 of those with a +2 charge total. And then on the right hand side of this half reaction we end up with copper, Cu, and ammonia, NH3. Let's look at the second half reaction. The second half reaction, that would be this right here. So S2O4 with a -2 charge total on the left, and then on the right it would be SO3 with a -2 charge. So now we have our two half reactions laid out. The next step is to go to the first half reaction and balance our elements out. So we have 1 copper on the left, 1 copper on the right. That's good. We have 4 NH3s on the left, but only 1 on the right. So I'm going to need to multiply this by 4 here to have 4 NH3s on the right, just like what I have on the left. Okay? So that now the elements are balanced. Let's check the charges. Over on the left we have a total charge of what? +2. Over on the right, charge of 0. So I'm going to need to add 2 negatives to the left, which would mean I add 2 electrons to the left-hand side. Okay? 2 electrons to the left-hand side. Now the charges are balanced. The number of elements are balanced. We're good. Now let's check out the next equation. Here we have 2 sulfurs on the left, but only 1 sulfur on the right. So I'm going to need to multiply this by 2. What does that do to the oxygens? I have 2 times 3 is 6 oxygens on the right, but only 4 oxygens on the left. So what that means is I'm going to have to add a source of oxygens, which would be water. Okay, we're going to do it just like we did with the balancing in an acidic solution. We're going to add waters. And so we have 6 over here, we have 4 here. We need to have 2 H2Os added. That adds 2 more oxygens to make a total of 2 plus 4 is 6 oxygens on the left. But if I add that many waters, that's 2 times 2 is 4 hydrogens. So I'm going to have to add 4 H pluses to the right-hand side. Okay? Now my elements are balanced. But how about the charges? Over on the left we have a total of 0 plus -2, or -2. Over on the right we have 2 times a -2, which is a -4, plus a +4. That gives us 0 over here. So 0 on the right, -2 on the left. So what we're going to have to do is add 2 electrons to the right-hand side. Okay? So that's now 2 times a -2 is -4, and a +4 gives us 0, and a -2 gives us -2 total. Here's -2 on the left, so it's -2 on the left, -2 on the right total. Now if we look to see the electron numbers, we see there's 2 electrons up here and 2 electrons here. So we're good. We don't have to multiply one of these half reactions by some number, because the number of electrons is the same for this half reaction as for this one. So they will cancel out. I'll just do that right now instead of waiting to add them up later. Okay, now I'm going to add the 2 half reactions. And we're going to get CuNH3 for the +2 charge, plus S2O4 the -2 charge, okay, plus 2 waters, then arrow Cu plus 4 NH3s plus 2 SO3, 2 negatives, plus 4 H pluses. And if this was in acidic solution, this would be the answer. However, this is not in acidic solution. This is in basic solution. And so we have one last step to do. And that is to neutralize the H pluses by adding OHs, because you might recall that a basic aqueous solution has excess numbers of OH ions. Basic means you have excess amounts of OH ions. So let's add, if we have 4 H pluses on the right hand side, let's add 4 OH minuses. And when you add OH minuses to H pluses, you get water. So 4 H pluses plus 4 OHs gives us 4 H2Os. So that gets rid of that. Okay? See what happened? Okay. So now by doing that, let's see what our final result is. Okay, I'm just going to write out the final answer in blue. CuNH3, 4, I won't even talk, let me just write, plus this. Now we have, I need to mention something here though. Here we have 2 waters and we have 4 waters on the right. So I need to subtract 2 waters now from both sides to consolidate them. And so we'll end up with 2 waters on the right and none on the left. So arrow Cu plus 4 NH3s plus 2 SO3 minus 2s, and then finally plus 2 H2Os. And this then is the balanced reaction. Okay? And remember, don't forget to do that one last step of adding OHs to your excess H pluses to form water. And then once you have that water, you need to consolidate, combine like terms with the water over here, and then get your simplified answer at the end. Thanks a lot, guys.